Okay, so let's just see if we can give this person a bit of an explanation about what an integral actually is. In terms of Kowalski, real analysis. He's really smart and it's intimidating. They're very self-aware. I feel like 90% of the time I'm just lost. I don't feel smart when I stream, especially now that like it's gonna people in stream are just smarter than me. So Jed's here, you gotta behave now. Yeah, it's a good one. Yeah, no, I just thought of it over the weekend. Your analysis today was wild. Yeah, it's getting it like last week, or it was like the very foundational stuff, I guess I'll say, where the problems weren't that bad. But I think we're gonna get into the harder concepts now. That's the second week, or you know, start to get into them. Someone make him draw. Derive position to get speed, and speed to get acceleration. Actually, okay. I want to explain this idea, but I need to put it into words better because it's how I think of it in my head. But see, we're doing a self-portrait. Yes. Oh, maybe you were there for that. But that was like when I first added that. There's a whole really funny sequence of events. Yo, Thunder! Thanks so much for the Prime. Yeah, you get those 2.2 times channel points for a tier 1 sub, something like that. But my Discord profile picture is a part of that, me being forced to draw a self-portrait thing. So I think Zach redeemed me drawing a self-portrait, and then Spetri redeemed me drawing a self-portrait, or me drawing a self-portrait, not two levels, and then the me drawing a self-portrait is what became my Discord profile pic. I might change it back at some point, but stealing Jeff Bezos' money, yeah, exactly. Definitely how that works. I appreciate it though. Okay, what am I trying to say here? Distance divided by time. And the idea behind, and if you do a very small distance over a very small time, we call that dx over dt, where x is distance and t is time. Dx over dt is just notation, not actual division. Polylagrangian, if that's how you say that. How do you practice solving math problems? Like, how long do you think about them before looking at the answer? It's not really a fixed amount of time. It's I look at the answer if I am stuck, I guess. If I've at least attempted to go down all the avenues that I can think of and I haven't gotten to the conclusion yet. Or I just don't know how to approach it in the first place, I guess. But yeah, like when you first see a problem, you can try to like outline different ways to attack it, and if you try to pursue each of those ways, and if you can't get very far, it's still educational to try it. I noticed that Danny Highway Dan is really good about actually drawing out potential approaches when he first sees a problem, and kind of like listing them explicitly, and trying each one or choosing the most promising one, or depending on how much time he has, I guess. So, I mean, actually, yeah, let me get his Twitch link in there, but I noticed that he in particular is very good at like explaining how to approach problems as well, if you ever have time to watch his stream. And I try to be good at it too, but I think he's better. It's a good way to proceed, yeah. On the flip side, so let's take out the acceleration part. We don't need acceleration for this explanation. And I'm saying speed in one hand and velocity in the other. Let's just keep things as speed. Speed to distance. V equals d over t. You do v equals v times t. Doing Olympiad kind of problems time to time, but you struggle to recognize what theorem to use. Oh, okay. I did just find an Olympiad math Discord. If you're interested in that, I can get you the link. I'm not good at Olympiad math, so I can't help you there. The name of this song, I just switched songs, but so I skipped back to the last one. Friendly Creatures by Kupla. Yeah, that song is playing right now. Okay, and I'm gonna skip forward again. Let me get the link to that Discord. There we go. Take a very small change in time. We call it dt. Of the rectangles involved in a Riemann sum. Okay, so this is kind of like my general derivatives and integrals explanation for like why they are what they are. Because it always was really confusing to me why area under the curve has anything to do with the antiderivative, but to me, it feels more like a happy coincidence where you're rearranging this like, velocity equals distance over time formula, and anytime you multiply two things, you can interpret that as getting the area of a rectangle. And if you take rectangles that are infinitely narrow and fix their height to be the height of the function, it turns out to also be the area under the curve. There may be some deeper reason why it's not a coincidence, but that's how I think of it. And I'm trying to convey that in this text response, and it's kind of hard. So let me, I want to copy this answer. Oh, wait, if I close, okay, good, I still have it. Happened to the blanket challenge? Well, I'm wearing my one blanket right now. I have been wearing a blanket over my shoulders, and it's kind of cold, but I feel like I should just man up and get used to the cold. So I'm trying to just live with it. And hey, Get Safe, how's it going? I'm doing good too. Glad to hear that you're doing great. You have nightmare fuel? Oh god. Dawn clean shaved? I used to be clean shaved. And I think I look way better with the beard. It's just sleeping. That's a great way to do that challenge. No, when I sleep, I have 5 blankets. Last night I slept with 5 blankets, 2 pairs of pants, and a hoodie. Because I refuse to turn my heat on in this apartment. You have to go to the army on Monday. Beard's gonna have to go. Oh wow. Frickin' hell. Good luck in the army, Got Saved. I hope it's nothing or yeah, that's like that to shave the beard, but it's also, unless it's something that you want to do, it's probably not going to be a very fun experience. I guess it depends on the country too, but I talked to a lot of people. Swiss Army. Oh, good. Okay. Yeah, you guys probably. Yeah, if there's any army I don't want to be a part of, I think it's the Swiss Army. Yeah, it's gonna be one of the lowest chances of getting combat, as far as I know, at least. Do they have? I guess they do have compulsory military service, right? You playing trumpet? Oh, okay, you'll be fine. Okay. So, people are Twitch. I'm never sure what country that they're in. So, for some reason, nice factor, a knife factory. Yeah. They also make cheese. Compulsory, so you find your way around it. That's a good way around it. So if you have dx or dy over dt equals, or shoot, dy dx, because that's how students usually see it when they're taking their earlier calc classes, equal to x squared, it's not technically, it's not technically correct to multiply both sides by dx. Dy over dx isn't really a fraction by dx and cancel them. No weird coincidence though. It actually can here anyway. Opt-in-pot in differential equations as separation of variables. Okay, I think I've kind of explained this to death with the last paragraph, so I should just hit save and post this. Okay. How do pulleys work? I don't think anybody really knows. Okay, this one doesn't have an answer. The two diagonals of quadrilateral Q are perpendicular. For quadrilaterals? Why does this shape disprove statement 1? Oh. Statement 1. One of the diagonals of Q is a line symmetry of Q? Oh wait, maybe it's given the diagonals are perpendicular. I feel like... Okay, yeah, so it's given that the diagonals are perpendicular, because I feel like they wouldn't always be. But maybe, I don't know. So, right here, neither of these diagonals split Q in a symmetric way. Hey, Mangoes. Thanks for hanging. Enjoy your lunch. Okay, before I type out an answer, let me go put my mug away because I'm out of tea. Okay. Viv, how's it going? How's your son doing? Does the California flag have two bear heads? Because it's the new California Republic, which is from Fallout New Vegas. It's like a faction in that game. So for the game, they like spoofed the California flag. In the Fallout world, like the entire world was nuked and things are like radiated. Is that not a quadrilateral? Yeah, it is. It has 4 sides. You being separationist? I mean, maybe I am too. No. Yeah, in the Fallout universe, everything is like nuked, and so animals have mutated, and they have a 2-headed bear. The dash line turn into a pyramid. Oh, okay, I see what you mean. The midpoints of the sides of Q are the vertices of a square? I think this picture disproves them both. Yeah, I didn't even look at 2. Gonna prove 1 + 1 is 2. I don't know if Zach is gonna take us to that level, but another math streamer, e to the 2y pi, aka Zach, has been teaching this live real analysis class, and so one just happened an hour ago, and I'm gonna do some extra problems beyond what we called for in the class. So, so yeah, it's Thunder. I think you're right. Counting some sleep before it starts, you might get PTSD. No. Let me. We've been talking about limits, and like in the concept of sequences, and in my own experience with like rigorous limits is, half going over epsilon delta limits in a calculus class, and I never understood it. But we're doing it in a very like different way that's so far been a lot easier for me to grasp. It's very like discussion based. But yeah, it's probably not going to be easy still, but I want to see how far I can get in the class, I guess. You don't have to say it again, but you will. You hate analysis? Oh, I know you liked algebra. I didn't realize that meant you hate analysis, though. I don't know. I never taken in class in either. I think I dislike algebra more though, from the little bit that I do know. Some delta's really fun, but at first it seems like they're pulling stuff. Yes, exactly, Viv. Trial becomes doable and even fun. I'll take your word for it. It seems scary. I haven't been recording this entire time, by the way. Okay, well, I'll pull it from my Twitch VOD. 35 minutes. Let me write down the timestamp. 35, like 10-ish. Twitch VOD. Okay. Judge was your only true love analysis evil. We make it arbitrarily small, hence proved. Okay, I think that this answers their question. Why does the shape disprove statement 1? Yeah, I hope it does at least. Let's see what's up with this one. Doesn't have an answer. That's probably not 0.75. Sigma looks like a gun. Oh, yeah? I've never seen anyone use this sigma. Yeah, because I've been trying to think of like emotes or graphics or something that involve like the Greek letters and what they look like, but I never can come up with anything. That's a good call though. Do you solve the Riemann hypothesis yet? No, I'm still working on it. You keep the prize, you just want the credit? Oh. I mean, if I solve it though, why wouldn't I take both? So they cut off the problem perfectly so that, okay, the 4 coins, okay. Someone you should write at the end of the word in Greek. Oh, interesting. Okay, so you're flipping, I assume 4 coins together, and the random variable h represents the number of heads obtained. Assuming the coins are fair, suggest with reasons a suitable distribution for modeling h and give the value of any parameters needed. Probability of obtaining more heads than tails is 5/16. Hey, Prev. I mean, isn't this binomial? Let's see if binomial gets the right answer for this. Okay, so we would take n as 4, p is 0.5, and if more heads than tails, if we say x is 2, and we want, we say x is 3, x greater than x, 3, 1, 2, 5, is that 5 over 16? Okay, yeah, 3, 1, 2, 5. Okay, good. So I'm not completely stupid, only partially. My dear mathematicians, the Greeks who pioneered math have long been dead. Please change notation to English. So I have to go through 4 years of using those symbols. I don't know if we're ever going to get rid of the Greek letters from math. I'm okay with getting rid of psi for sure. My professor always said psi, but I think it is just pronounced psi. Oh, you guys can't hear that because my opera audio doesn't come through. Get rid of pi? Then if our species survives. pi is cool though. I like pi. Okay, so I'm not sure why they're getting 0.75 for more heads than tails. Tau gang? Oh yeah, Tau's cool too. You know, I was just getting mixed up. The other day we were doing radians to degrees, and I kept thinking that pi is 360, and I'm like, why is pi not 360? And I guess maybe I'm part of the Tau gang too. Viv, you hate Tau though. Why? It's just worse pi? I mean, it depends on how you think, I guess. I feel like there's a better explanation that I could give here. Having to do with like the choose part of the binomial distribution, like you have to account for the different permutations of like how many ways there are to get 3 heads versus 4 heads, which I guess maybe that is the explanation right there. Some probability table. Oh yeah. It's not as simple as yeah, okay, yeah. There's only 16 outcomes, Viv. Yeah, that's a nice way. HTH, HTHH, THH, HHHH. There's 5 desirable outcomes. Another way of thinking about it is that there's 5 desirable outcomes and 16 total outcomes. Oh yeah, guys, I just used a calculator, but you're right. And the binomial distribution base just accounts for these different cases. Something you hate about schools is that they don't explain the beauty of maths, just make you mug up formulas, but 90% of school kids who complete the square don't know it's actually derived by completing the square. Yeah, I mean, I think that's a mix of teachers. Well, okay, there's the issue of how do you ensure students are actually learning things at a high level, like if you're like a state legislator or whatever, and the answer is usually standardized testing. And then teachers either don't care or they have to teach to that standardized test. And then students also generally don't want to learn because they're forced to be there and go to school in the first place, and they don't really want to be there. I don't know, it feels like there's a few factors that all like count towards like encouraging just rote memorization and not conceptual understanding of math, and I don't know how you solve it. I get a little bit nervous when people post 2 full pages of stuff. Let's see what this is actually about, though. Oh, come on. This is like a big project, it seems. What are they asking? Okay, so I think they're asking about like this last box and the sub boxes below it. Okay, so they're asking how the specific characteristics of a function affect the rate of change calculation. So we talked about like asymptotes for rational functions. Would the periodicity of a trig function affect the rate of change? Not necessarily. Discontinuities. Wait. Discontinuity. Okay, I think I spelled that right. Are discontinuities. So I don't know what else to warn this person of. Like, trig functions are periodic, but that doesn't really affect much. Instantaneous rate of change. Okay. So let's see what Viv posted. Then I'll take a look at what Thunder posted. Oh, this is an example of a problem off there. A chess tournament has 2 to the n players with skills 1 greater than 2 greater than ... 2 to the n. It is organized as a knockout tournament so that after each round the winner proceeds to the next round. Except for the final, opponents in each round are drawn at random. Oh, interesting. Okay. Also assume that when 2 players meet in a game, the player with better skill always wins. So the players 1 and 2 will meet in the final. Wait, the 2 lowest skilled players meet in the final? Hey, Bob, yeah, it is a... it's probability, but chess is involved here. The player with the better skill always wins. I assume that... Wait. What's probability here? If the better skilled player always wins... Oh, wait, so... maybe that they don't meet until the final. The top... I'm taking player 1 as the top skill and player 2 as the second top skill. Because if it was the 2 least skilled, that just would never happen. Unless that's the point, it's a trick question, and the answer is 0. But the first 2 players are the only ones in the final. Oh wait, 1 is greater than 2. Wait. Oh, I get it. 1 is the top skilled player. That was tripping me out. Okay, 1 is greater than 2 for the sake of this question. Okay, that makes a bit more sense. Player 1 can match with all players above player 2's... Or are they arbitrary skill level? Because either of them could be the top skilled one. If there's 2 to the n total players, it's 1, 2, 3, all the way up to 2 to the n, I think. It's a really fun problem. I'm very bad at these types of questions. I'm still like, I'm still not sure. Like, so players 1 and 2. The way you're talking, Viv, it sounds like players 1 and 2 are just in like somewhere in the middle. Or it's player 1 the best skilled player and player 2 the second best skilled, and it's just probabilities of them not meeting until the end. This is the answer? Okay, I think we need to look at that, because I'm like... Player 1, okay. Or maybe before I look at that. Player 1 and 2 could be any skill level. It's probability they meet in the final. Oh! And they'll only happen to meet in the final. Okay. So... I see. If they're any skill level, what are the different scenarios where they would meet in the final? And so if player 1 is the best skilled player 1 could in theory knock out all the people above player 2. So player 2 could be a lot lower down. I see. I think... Yeah, okay, so I definitely want to think about this more before I look at the answer. So I'm thinking that one of them must be the best player, because that player never gets knocked out, and they're going to go on to win the tournament. Okay, yeah, and so that's what you're saying too, Viv. So you have to take both cases. They're really the same case, so you can just do one case and multiply by 2, as you said. And so if there's 2 to the n players, I think, okay, let's go to the whiteboard. So this question has me intrigued now. In Thunder, I'll look at yours after, since it was just a for fun question anyway, and so was this. Okay. So we'll just say player 1 is the most skilled. Then okay, so you gotta go, you'll delete your question. Oh, okay, Thunder, sorry about that. But yeah, I'm happy to take a look at it another time. Okay, so how many rounds do we have? Oh, well, actually, okay, I think we need to... Each round you knock out half the players. So maybe we need to figure out how many rounds we actually have. That feels like it's going to be relevant. With 2 to the n players... If you have 2 to the n over 2 rounds, is it that easy? I feel like we need to adjust plus or minus 1. Because if each round knocks out half the players, if we made it easy and we had 4 players, you'd have 1 round to knock out 2, another round to knock out 1 is the finals. Okay, so that's 2. And that is just 2 to the n divided by 2. If you have 8 players, 1 round knocks out 4. Another round knocks out 2. Another round, that's 3. So do you have n rounds actually? Yeah. Okay, then we just came to I think it's n rounds. Actually, that makes sense too, with term brackets being easier with powers of 2. Okay, so we have n rounds, and so I think that's relevant because there's a gap in skill potentially between player, or there is a gap in skill between player 1 and player 2. And player 1 can only eliminate so many players above player 2 as there are rounds. So maybe let's just manually talk about a few scenarios here. If P2 is equal to 2, let's just say, no special requirements. Like, they can be matched with anyone, and it doesn't matter. If P2 is equal to 3, P1 must beat 2, or skill 2. Before final round. And so that's going to be probability. Because you have n rounds in 2 to the n minus 1 players, or you have n minus 1 rounds in 2 to the n minus 1 players, because the finals don't count and player 1 doesn't count. Player 2 doesn't count either. Actually, it's a special requirement. They must not meet. They can't meet early. Which is true for all these cases. So the chance of player 1 meeting with player 2 is 2 to the n, or the chance of player 1 P of P1 not meeting P2 is equal to what, like 2 to the n minus 1, or 2 to the n minus 1 down below. That's not right though. How are we gonna actually calculate this probability? I think like 2 to the n minus 1 over n minus 1 or something like that, but that's not less than 1. Oh, Zach! Yo! Hope the rest of your stream was good. The real analysis was awesome. I'm working on this problem from Never Gonna Viv You Up. It's just a for fun problem, but it kind of has me intrigued. It's down in the lower left corner of the screen. I've just been trying to kind of wrap my head around it here. Because I'm really sure with like how you actually calculate probability out of this, because I'm just not that good with probability. So also, oh yeah. And so these are your probability. So you're given player 1 and player 2, and you want to see when they'll meet in the final, and you're not given what skill level they are. I think I have it worked out where one of them has to be the best skilled player, because the best skilled player in this scenario is just always going to be in the finals and always going to win. But the other one, they not necessarily the second best skilled player. They could be the third, fourth, fifth, maybe even more best skilled player, and just have player 1 do the dirty work for them of eliminating the people above player 2. And I'm not sure. I'm trying to figure out how you work out that probability. That's what I'm like kind of struggling with right now. So what I have right here is that if player 2 is the second best skilled player, the only condition you have to worry about is that they can't meet early. And I'm trying to figure out like, oh, it's 2 to the n minus 1 over 2 to the n for a single round. And then since we have multiple rounds, we raise it to the power of n. Okay. I like this. So player 1 not meeting player 2. Thanks for lurking, Zach. Does this turn out to be binomial, I wonder? I feel like it's going to be something like that, but... Or maybe like geometric, or there's even like potential, like if you take a limit, there's like some E business happening, maybe, but let's not get too far ahead of ourselves. So if I'm happy with that, it may not be quite right, but let's just keep going. If player 2 is the third best player, then we need probability, I was going to say of the above, is equal to so player 1 has to beat the skill level 2 person before the final round. Oh wait, that's n minus 1. Because we're only about n minus 1 rounds here. The probability of them meeting the final for third's best skill level. We need I'll see, there's a few different, I think it's going to be binomial in some way. Because we have different combinations here. Because player 1 could meet... Oh, but you also need you'll need player 2 to not meet the second best player as well. There's n minus 1 days until the final. Oh yeah, I got saved. I don't remember when you said that, but I think I realized that for myself. I kind of wrote it small too, so I'm not sure how legible it is. Oh, physics and depression. How's it going? If we set up the brackets, doesn't this simply come down to probability that one player is in the left bracket while the other player is in the right bracket, i.e. 0.5? Oh, does it? Well, the brackets are randomized each round. I think is maybe the issue. It's not a consistent bracket. Like the pairings are random. Each round. And minus 1 chance for the second best player to get eliminated by number 1. Otherwise, they meet at the finals. Yeah, no worries. Yeah, I got saved. And so probability of them not meeting, I think, is 2 to the n minus 1 over 2 to the n, and then it raises to n minus 1 power. And I know that actually, maybe, can I write? Let me try and write that bigger. So it's probably an important part of the problem. So that's the probability, I think, for this first scenario. And we're going to get like a summation here. So it's a knockout tournament. I think it's what you've been describing. It's just instead of a consistent bracket, it's like in a normal knockout tournament, like I think most people think of, let's just say we have 8 people. Shoot, how's this supposed to look? We're like, you know, player 1, 2, 3, 4, 5, 6, 7, 8. That's in 8, I promise. So normally, let's say like player 1 wins and player 3 wins, and then they would, since they're on the same side of the bracket, they would meet. But in the format that's described by the problem, you would take these 4 winning players and randomize them again. So instead of 1 playing 3, 1 could play 5 or 7 as well. And then 5 could play any of the other 3 each round. 1 is paired with 8. Oh yeah, you're right, if it's seeds. But you know, just for the sake of like explaining what the concept is. So that's like the normal way where like, you know, 1 would play 3 after this, but I think in this specific tournament, they're taking this entire column and like randomizing it, is my interpretation here. And that's where the probability comes in. Well, I guess there's still the probability that you said, but reverse build a bracket regardless of who wins each game. But then you already know the outcome, don't you, Jeff? Unless I'm not following you. So 1 over 2 the improbability that 1 faces 2 in the first round, 1 over 3 faces each other in the second round. Oh, I might not have set up my probability correctly. Because, yeah, each round they're going down, the number of players are going down by half, aren't they? Geometric series, I think. Viv, you haven't missed the whole time, just trying to sort of like understanding the problem. I think my probability here, even for the very first scenario where we have the 2 top skilled players, it needs to be a bit more complex than what I wrote here. Because player 2 could be like the 3rd best, the 4th best, the 5th best, and player 1 just does the dirty work of eliminating the people above player 2. But maybe let's just look at the case where they're the 2 top best players and worry about the rest later. Yeah, it's something like that. It's like, yeah, in the first round, player 1 not meeting player 2 is 1 over 2 to the... No. The chance of the meeting is 1 over 2 to the n minus 1 like that. But if we want the probability of them not meeting, which is what we care about, we'd want to do 1 minus that. So we get 2 to the n minus 1, which is, wait. I messed something up there. That's -2 up top. There, that's what I messed up. Keep the complementary probability, then subtract it from 1. Oh, that's a good point. Yeah, I was only focused on the one track, so you're right. We should keep our options open if we can, though. Each player has a 1/2 to the n-1 chance to be one's rival. Oh, like looking at it from that angle, Viv? Hello, fellow Californian. Oh, yes, I am. I didn't know that you were in California. The flag itself is from the game Fallout New Vegas, but I am also in California. In California. You just learned about that? Oh, okay. So yeah, it felt appropriate to have the NCR flag. You're in LA for a few weeks, but you're based in the Sacramento. Oh, cool. I'm in like the South Bay area. I've only been down to LA a few times. It's really busy, but there's like cool stuff there. I'm kind of stuck on what Vid said now. That's a completely different way of thinking about it. I'm not sure where you take it, but it feels like a good hint. Each player has a 1/2 to the n-1 chance of being player one's rival. Because I guess if we do it this way, we have to consider a lot of cases. Well, I mean, the thing is, even with that approach, and maybe it's actually not so different, we would still need player one to eliminate people above player two. And -1 rounds before the finals, right? So we would need, I mean, it won't be a simple exponent though, because the players get reduced by half each round. So I guess we could just keep on going down with this train of thinking. Like, what's the probability of them meeting? So that's the probability of the two meeting in the first round. In the second round, it would be 1/2 to the n-1 over 2? Floor? That feels a little wrong. Probability n-1 times that. The reducing by half part, I'm not sure of. Hey, Anders. GetSave is saying 1 minus 1/2 to the n-1 plus plus 1/2 squared minus 1. Oh, okay. Oh yeah, just doing the exponent -1. Yeah, okay, no, that's the way you're supposed to do it. Okay, that makes a lot more sense than my stupid dividing by 2 thing, even though it probably comes out to be a similar 2 to the n minus 1 plus 1 over 2 to the n minus 2, now minus 1, plus dot dot dot. I was getting tripped up on when you subtract the 1, I guess. Okay, so that's a good call, get save. 2, we don't want 2 to the 1 because that's the final, so we stop at 2 to the 2. Okay, so that's chances of the meeting before the finals. Okay. That's something. So, Jeff, player 1 and player 2 are, in theory, any skill level, but we've worked out that one of them must be the best player in order for them to make the finals, or in order for this whole thing to work. But as the question is stated, you're not given that information. And player 2 can be, in theory, there could be a pretty big gap between player 1 and player 2 if player 1 happens to play the people above player 2 and do the dirty work for player 2. You know, ignore all that. Probability I came up with goes to 0 as n goes to infinity. Probability that 1 and 2 face in semifinals is 1/3. When there's 4 people? Okay, yeah. Why is 1 greater than 2? That tripped me up too, Anders. Some ways to was phrased. I thought that too, Jeff. But it's not. Player 1 and player 2 are just any arbitrary players. We only need to consider the scenario where one of them is the best player. Because otherwise this thing doesn't work. As far as I know. Actually, yeah, no, it just doesn't work. Okay, so this is a scenario if player 2 is the second best player, though. And that's if they do meet early. So the probability that we'd actually want for the problem is 1 minus all this. For that scenario. Now, if maybe now we're ready to move on to a different scenario where, let's say, player 2 is the third best player. So there's one player between player 1 and player 2 in skill. One third plus 1/7 plus 1. Okay, so calculating the sum, basically the opposite direction of what I did. Is there a pattern that we could get there? Well, I guess this is the pattern here. Powers of 2 minus 1. Which isn't geometric. It's nearly geometric. Okay, so like we're doing the pluses here because it's all ors, because they could meet early in the first round or the second round or the third round, and if you negate that, it switches around to be the same as and, or you do like 1 minus that, it covers your and, I think. I might be getting mixed up with the computer science, De Morgan's thing, but that's what I'm thinking of right now. This song's kind of a banger, by the way. I may like it. Wait, do you not like songs? anymore? Oh yeah, you can. Okay. Okay. So if player 2 is now the third best player, then we have player 1 and player 2 can't meet early as above. And P1 must beat skill 2 before P2 meets skill 2, which seems really, I don't know how you, this feels like it's binomial or something like that. Because I guess for the first part, we calculate up here with 1 minus that. And multiply it by whatever we get for like this last part, but I don't know how that last part is going to take some thinking. For n equals 4, 5 over 16 chance of no meet in round 1. Yeah, Jeff. So I guess let's see if we can work out P1 beating skill 2. So in this case, P1 wants to meet skill 2. In the first round, does this turn out to be the same thing? Oh wow, this playlist looped around. 1 second. Additional probabilities. Yeah, it's getting a lot more complicated. I might take a peek at the solution soon here, because I feel like it's an interesting thread, but I feel like it's getting complicated. Not sure. General problem's hard. Markov chain. Oh gosh, I haven't done Markov chains. Yeah, it's sort of from a book that's like with like common interview questions. Which, if I had this on an interview, I would fail that interview. Clearly. I think Viv posted the answer earlier. I don't know if Viv is still here. Let me scroll up in chat, see if I can find it. Oh, shoot. Viv, if you're still here, I think something went wrong with copy paste for the answer. Because the link is just that, which is the homepage. Oh, shoot. Actually, I'm not showing my browser enough. Yeah, the link is just that you posted. They don't meet in the first round. Do the n-2 over 2 to the n-1. Yeah. Ah, shoot. I assume Viv had to leave. Let me... Hawk Hammer Q symbol. No, I had never heard of that. Let me see if... I don't want to do it on stream. Let me see if I can figure out how to get the book that Viv sent me on my computer. Because I assume the book has the answers. Yo! Boodib, thanks so much for the sub. Ah. Wait, that's not even the right browser. Thank you so much for that, Boodib. I really appreciate that. Wait, where did it download to? Also first? Yeah, you had the big first right by your name, so you must have been first. Where did this go? So I didn't want to do this on stream, so I'm being stupid. Downloads. Oh, maybe... Ugh. Okay, let me do it a different way. Sorry, I promise I'll bring it up soon. Download. Okay, there it is. Yeah, Bootip, I agree. But then this browser is annoying. Let me... You know what? Okay, better idea. Probably worse idea. What is this page? Oh, I have my own stream. Oh, I had Zach's stream open and then Zach rated me. I was wondering if my own stream was open. Okay. There. Six or 7, 14 or 15. Yeah. But this is like all I've considered so far is just the case where player 1 and player 2 are the top two cases. Which or the top two players, which yeah, but it's a little bit hard to understand what's happening with the question, but okay, page 68. Light speed. Okay. This is the solution here, so if you don't want to see the solution, then I suggest you look away or mute the stream or something for a bit. But I'm curious to see what's up with it, so I'm going to scroll down now. Spoiler alert. There are at least two approaches to solve the problem. Standard approach applies multiplication rule based on conditional probability, while a counting approach is far more efficient. Oh, okay. Now, should we already try this method? We can think and turn it from top to bottom. Should we subdivide in two halves at the semifinal? So I think it's kind of similar to what I think Jeff was saying, a similar idea, but I wasn't sure how to pursue it. But Andrew, I think it gets a little bit messed up because each round is randomized. And so Jeff is saying that that's not a huge deal for that backwards approach, but I personally didn't understand why. But I guess maybe this the solution will cover that. So they start with a conditional probability approach, which is easier to grasp. N rounds, including the final. Okay, so we got this 1/2 to the n minus 1 part. Oh, Biv was giving me like the very first step here, I see. Probability that players 1 and 2 don't meet in round 1 is 2 to the n minus 2 or 2 to the n minus 1. Okay. Oh yeah, no worries, Anders. Hair greater than 1/2. Oh. Oh, okay. Let E sub 1 be the event that 1 and 2 do not meet in round 1. One, two. Meet in the nth game. Oh, I see what you're doing, Jeff. I was like, what did I type? And then no, you're speaking agitator. Oh, it's just 2 to the n minus 1 over 2 to the n minus 1? Was I way overcomplicating it? Oh. The counting approach. Second approach. Okay. 1 minus 2 to the 1 minus n. Does that work out to be the same thing? It might if you mess around with the denominator or something. All right, cut save. Thanks for hanging out. Hope you have a good night too. Oh my god, I'm getting so lost in this wording. Each group of 1 player. Okay. This might be similar to what you and Anders were saying, but maybe in a way that is more consistent with the problem. Wow. Dividing up into subgroups and dividing Oh god, okay. I feel like I need to think about this when I'm like not on stream and trying to keep things moving because I'm gonna be stuck on this for a long time. I'll take some screenshots and post this in my Discord though, because it's a pretty interesting problem. If someone else wants to go through it as well. Her maps, this is pretty funny. Okay. Don't solve it though? Okay. Viv sent this to me as like a Discord file. I could send you a link to it too, I guess, if Viv is okay with that. But it's like an entire book. It's not just the one problem. UBS Merrill Lynch. Try to be helpful, stuffed each cover letter into each of the envelopes for you. All 5 cover letters are mailed to the wrong firms. You don't mind? Okay. That is a funny problem. I'm going to post the actual problem and the solution just directly in my Discord and screenshots here. And then... Okay, the spoiler solution is posted in Discord too, and then Anders, let me get you the link. I need to find your Discord. There's your Discord. Message. Okay, there. Oh shoot, I had to use a friend on Discord. Anders, I can actually DM you the link to the book if you want it, but if you just want the one problem, then it's that. I'm muting. Okay, I was about to move on and tell you that you could unmute. Oops, not that. There. So, physics and depression, did you want to see the solution from the book, or do you want me to, I guess, hide it again? Oh yeah, so this is the answer here. You'll catch the VOD? Oh, okay. And so this was the second possible solution involving counting. They did it a second way with conditional probabilities up above. So either way, it works out to 2 to the n minus 1 over 2 to the n minus 1. And that's what you got? Oh, cool. Okay. I think right now I'm going to go back to looking for homework help problems. That was kind of a fun little detour, though. Where is the error? Try solving some... Oh, God. Gaussian elimination. Let's see. That's not too bad. This got them to the right answer, apparently. This item got a wrong answer. Oh, geez. This person, they take notes like I take notes, and that's not a good thing. Oh, I can blame them. Oh, it's gonna be dumb. So this is the first one that apparently got to the right answer. So let's just look at where they deviated. This first step is the same as this first step. But this third step is slightly different. They did 3 plus 2 over 3. And here they did 3 plus 2. Or 3 plus 2. That's stupid, but... Or it's the way that I'm saying it is stupid, not what they're doing. You avoid handwritten notes, but probably people who need the most help. Oh man, I only do handwritten notes. If I type something down, it falls out of my head 2 seconds later. If I write it down, I actually remember it. So, on Reddit? Oh, okay. I mean, for this, like, good luck typing this stuff out. With the question, I mean, it is easier to read, but this would take so long. Hey, I don't know how you pronounce that. I want to turn the X into an A and say Tasky, but are you a teacher/professor? I am not. I used to be an actual tutor working in a tutoring center, but I have a bachelor's in applied math. And I'm enthusiastic about math, but I'm not an actual teacher. The 4 in the last row is not right yet. I'm gonna say I didn't actually even look at their work yet. So okay, in the step before, you misread? Okay. I'm not Dr. Don does math. No, I'm a fraud, Jeff. I know. My legal last name is does math. Hey, Henrik. Yeah, it's an augmented matrix. They're asking, apparently there's an error, I guess, on this step as it goes down to this step, or from the step from where they went before. I'm not sure exactly. I assume on the next step, though. So they did +3. Wait. Did they add this to itself? Oh, okay, so they multiplied 3 by 3, then they added 2. You're doing that right now in algebra? Oh, cool. So the foreign origin is pronounced Dosmef? Oh, I was like, well, what are you referring to? But yeah, Don Dosmef. Okay, so there shouldn't be a difference between taking 3 as it is and adding 2 divided by 3 versus multiplying 3 by 3 first and then adding 2 as it is. It's probably an arithmetic error, probably. So if you multiply 3, you get -3, 12, 12. And then you add 2, you get 0, -9. No, +9. They were right. 15. And what did their other work say? 3 and 5? Do they just think it's an error? But 9 and 15 is the same as 3 and 5. What actually doesn't match besides that? 3, -3, 3. It looks like it's the same. Do they get to the same final answer? 9, -12, 9, 9, 9, 15. Oh, you get weird fractions? Oh yeah, because you divide by 9. Sub 2 looks the same also? Yeah, I think they're just confused on this final step. You divide each of them by 9, and the fractions simplify to be the same. -4 over 3, 1. Oh wait, that doesn't come out to be the same. What is the answer supposed to be? Wolfram? It can do augmented matrices, right? Oh. If I give it the 3 by 3 as one matrix and the vector as another? No. Oh, God. Okay. Augmented matrix. I mean, I'm sure Wolfram Alpha, there's a way to do it. I just don't know how. I'll frickin' Opera. How did the VPN get turned back on? I thought I... Augmented matrix solver. Really? Okay. I'm apparently too stupid for that one. Okay, this is what I want. 1, -1, 2, 1. 1, -1, 2, 1. Wait. Now reducing feels like Sudoku. Okay, there. Make sure I'm copying it from the actual problem. Okay, 1, -2, 2, 1. 1, 2, -1, 4. 1, 2, -1, 4. -3, 2, -2. -3, 2, -2. What was the last one? 1. One third, 8/3, 5/3. 1/3. That is 8/3, 5/3. Okay, so that's the right answer there. This would be... Ooh. Yeah, it should all be positive. Where's that? Is this red arrow irrelevant? The first thing... Oh, the first thing I did differently is marked. They made an error later on in their work. Watch, someone probably beat me to answering this one like 10 years ago. No, not yet. Okay. So where does it stop matching? That seems like the most direct way. Gonna be here for a while. Hey, LT, you hate grading row reducing? I can see why. Jeff, I'm probably do math for another 50 minutes or so, ish. Yeah, I'm feeling the pain right now, LT. I'm going to be doing math for another 50 minutes. So I'm going to do a video game tonight as well. Okay, so they did 9 times 1 minus 2 times 3. Why? Why would they do that? When Cloud, you have to unleash on someone else? Oh, thank God. This is a very strange step here. Why do you multiply the first row by 9? Can you just multiply the first row by 3? Oh, wait. 9, -9. Are they getting the 0 there? They could have gone for 6, couldn't they? I guess 9 and 2 also works. Wait, x2 isn't right? (2i plus 3) is wrong. Okay, or 3 times 2 plus 3. Multiply 3, you get all 9s. What order are they doing this in? Just that you don't say do code and help with coding. I do basic coding. I am not very helpful at fixing other people's code. I can try. Jed is a coder and can sometimes help too. So if you had the actual code like they can copy paste and show to us, we can try and troubleshoot it. But if it's like a conceptual question, there's a good chance I wouldn't be able to answer it. Hey, Scorpra. So okay. -9 plus 3 comes out to be 0. That seems okay. 9 plus 15. They didn't do the plus 15, did they? That should be 24. And 24 over 9 simplifies to 8 over 3, which was the answer for that row? Okay. Nice spot, Stooky. Actually, since I always forget, you remember to add a save. Your errors later on. How do I describe this? We did 3 times 2 plus 3, I guess. Actually, is there a second error, or was that their only thing? Making this error also messed up their other one. Was 9 and 15 is 5 over 3. Is that the answer for x3? It is. Okay. And so that did mess up their answer for x1 as well. Okay. I think I'm going to switch over to the real analysis stuff. Yeah, oops. Because I want to do some of that today. And I've been doing homework help for a bit. And I'm still having to help with homework if someone comes in with a question, but I'm going to get some real analysis studying. So Bob and I did 1 through 6, skipping over 4b. So let's start with 4b. And what is the Greek letter that looks like Z? This isn't really important. I just want to know. Or is that just a Z, maybe? There's the capital Z, but I don't think it's zeta. Okay, I guess it's non-important. Maybe it is uppercase zeta. Who knows? Because that's lowercase zeta right there, right? Yeah. So find the limit of this sequence. Psi is off. It's my least favorite one. And I don't, looks like, I guess it's pronounced psi, but my professor's always said kasai. So that's also been like messing me up when I've been talking to other like math streamers and all that. But yeah, no, psi is the worst. So yeah, this is spoilers for the real analysis that's happening tonight, if anyone's going to be a part of that. So just be warned that if you're planning on participating in the real analysis section 2, these are things that you're going to see. And it's up to you if you want to keep yourself spoiler free or not, I guess. But I'm in section 1, so I did this stuff this morning. And I want to continue some of the problems. See? Oh, for me it was Kasai, the Greek way of pronouncing it. Greeks will say P, the battle has been lost on that one. Psi equals chi, you know, maybe. It's actually one superiority. Okay, so, and Bob, you know, as always, if you want to hop on and work it through with me, please feel free. And if not, then no worries. So I'm going to call that Z, because I don't know if it's zeta or Z, but I'm calling it Z. 1 over n plus 3 from n equals 1 to infinity. I need to bring up what we were doing as part of the class. It's going to be super spoilers, because it's the work we're doing for all the problems, so just be warned. I just want one of these lines, like this first one here. For any epsilon greater than 0. Actually, it's fine. Actually, yeah, my browser was cut off too, and I forgot about that. The empire died 1,000 years ago. They should learn to speak English. Serious, you mean modern Greek? You have no idea the pronunciation is different. Oh yeah, I'm not sure. I've heard that Greek has changed like very little, if at all, from the ancient ways, but I don't actually know that. So we would suspect this limit would go to 0. So, oh my god, I need to remember how we're actually like, because we're given it's convergent, we know that z sub n minus 0 should be less than epsilon for any given epsilon greater than 0. A Greek keyboard? Greek yogurt? That's a start. Okay, and we know that z sub n is that sequence. 1 over n plus 3 minus 0 is less than epsilon. And n starts from 1, so this is always positive, so we can get rid of the absolute values. Solving this for n, 1 over epsilon. No, well, yeah, it's fine. N plus 3. Do I flip the inequality there? I multiply by n plus 3 and I divide it by epsilon. That's the same thing as flipping both sides, so I do need to flip the inequality. That makes more sense. Wait. Why am I confusing myself? I flipped it twice, I think. If I just flip both sides rather than multiplying and dividing, n plus 3 is greater than epsilon. N is greater than epsilon minus 3. Okay, that makes more sense to me. Am I tripping? I lost a 1 over? Oh, you're right. I flipped both sides, but I also didn't flip both sides. There we go. Now, we have an issue here where this is negative. No, we don't. Well, for certain epsilons, it is. But we can just also say, no, not greater than. We can just take our big N as 1 over epsilon minus 3 plus 1,000, like we're doing with Bob, then ceiling. Thinking just 1 over epsilon. That's true. I mean, anything that's greater than that would work, so. Okay, so that's like, it's like the scratch work step. But we need to actually prove the limit. We need, let me see how much of this I can, you know, not just like memorize by rote, but just like trying to figure it out. What Bob was doing was a more, like for all epsilon greater than 0, there exists an n belonging to n. I think is how we're doing it. You know, something like such that. Oh God, no, I can't remember it. Let me just look back at it. There exists in such that for all n, yes. Yeah, what Jeff is saying. For all small n greater than capital N, there is c sub n minus 0 less than epsilon. Okay. In this case, our L is 0. And then from here, we're going to take our choice of big N, knowing our scratch work is this. N greater than N equal to, you know, I'll just write the thing that I did here, even though there's many other simpler versions that you could do that'll have a little bit less steps, but I'm just going to do it the way that we were doing it earlier today. So this is true, and then we also have n greater than 1 over epsilon minus 3. Because, oh wait. Yeah, because if n is equal to this, then n is greater than this. Okay. Then n plus 3 greater than n plus 3. I think I'm going to trip myself on this algebra again, but, well, actually, no. Actually, well, then that inequality flips. Maybe I'm doing this, let's not worry about the small n. We'll work with small n in a minute. And if this is true, then this is also true. And if this initial statement is true, you could also say that small n, which is greater than big N, is also greater than this. And then you can do the exact same stuff. Actually, I guess you really should use the small n. And that's our original thing. What's the purpose of doing with the big N, actually? Now that, because we were doing with the big N. But I feel like after you go with this step, you just say n, small n greater than big N, and then you work with small n for everything. Oh, and I'm partially blocking it. Or partially blocking my work, but... It's valid? Alright. Let's go and look at another one then. Oh! I don't know why that keybind also changes the Firefox tab. Kind of annoying. Confused about how the argument goes? Okay. I'm confused about it too, because I was only just learning this argument. So, if my understanding is correct, Anders, this stuff on the right side here is all kind of scratch work. Just by intuition, I think that this sequence is going to approach 0 as n gets large, just, you know, from using normal limits. And in trying to figure out a big N for us to choose as kind of the minimum sequence term that's going to be less than epsilon, that'll give us, like, you know, that'll give us a difference in less than epsilon. We set up this kind of I guess relationship, because we know that we're given the sequence converges, and the convergent sequence has this relationship to be true. And the goal here is to figure out what n we want to choose given an epsilon. So we rearrange this to be in terms of, or to be n in terms of epsilon. And because you can choose any point after this, I just did plus 1,000, even though it's not necessary. And I'm explaining it horribly, but this is all just scratch work to inform, like, the next part. Plus 1,000 overkill? Yeah, Zone Ranger. Just 1 over epsilon would have been fine too. I guess I could just do that. If we want to be even better about it. It only affects that first step there. And then once you've done that scratch work, we come over here and we want to show that for all, after a certain point, big N, all the small n's are going to be within epsilon, away from the limit. And so, you know, out of thin air, or from the scratch work that we did here, we'll take n is greater than 1 over epsilon minus 3 and resolve it back. I'm a little bit, like, I'm still trying to wrap my head around it, because I'm not good with this stuff at all, but, like, that's kind of my understanding of how the logic goes, which I explained horribly because I don't understand that well yet. 1, take an arbitrary positive epsilon, choose the appropriate n, prove a sub n minus L is less than epsilon. Class of the chain of equalities and inequalities start from a sub n minus L and end with epsilon. So I think that's what I was trying to do on the board here. The choosing the appropriate n part is my section on the right side. And the actual proof is on the left. I think. Again, I'm not good at this stuff, so if there's a logical error, it's possible I just missed it. If and only if all the way in, that is the proof. Okay. The last step is written backwards. Like, this here should have been done in reverse. But this is what we want to show, isn't it? Or can we start from that step? Because that's like assuming the thing to be true, I thought. So again, I'm really out of my comfort zone with doing this, so. Let me get a cough drop. Okay, in the meantime, I think I'm gonna start looking at the next problem. Oops, that's not the right one. That one. Okay. So the next one is 7. Skipping ahead a few. Oh, there's Andrew his thing. Can we take this back down for a second? C sub n minus 0 is equal to 1 over n plus 3 is less than 1 over n plus 3. Right? Because small n greater than big N is equal to 1 over epsilon minus 3 plus 3. Oh. That seems valid too. I don't see an error in either of those. I wonder if they're just two different ways to do the same thing. I don't know. Might be something that I'll need to ask Zach. You know what I'm saying? I only tenuously understand it best, so. Yeah. No, I don't know what's right here, so. You may very well be right also, or you're more right, or I don't know. But at least I mirrored what we were doing earlier, so for now I'm going to let that one rest. So skipping ahead to question 7, are all sequences bounded? No, something like n or n squared aren't bounded. If no, are there... Well, no. I guess n squared is bounded from below. But just n or n cubed. Okay, yeah. It is broad, Anders. I'm kind of curious. I don't know how this one is going to work, but actually, yeah. So my example with n not being bounded actually isn't quite right, because we only deal with the natural numbers here. So that's still bounded from below because you only take the positive ones. What Bob put with -1 to the n times n isn't bounded. Make a conjecture, prove your conjecture, you know. I do like how it's broad enough that your conjecture could be literally anything, you know. My conjecture is that 1 is a number. So the question does say may be bounded, not must, or covering every like situation. The idea that this convergent implies bounded. I like that because my mind was going to like if it's a decreasing and bounded from below or increasing and bounded from above, which is just a fancy way of saying convergence. I was making it too complicated. So if a sequence converges, it must be bounded. But if it doesn't converge, it may or may not be bounded. We just don't know in general. Now, the conjecture, I guess, that is natural to make here is that what I just said, if a sequence is convergent, it must be bounded. Or, yes. And I think that's going to involve rearranging a limit, but no, the definition of a limit assumes that it's convergent in the first place. Does it not? We need prompt 1. No, so we could maybe still use this to actually prove it. Because we're only talking about convergent sequences, so we definitely could use this fact. And I assume it's going to be helpful. So if it's convergent, it must be bounded. The absolute value is messing me up. Because you'd have something like sine x or sine n over n, where it's alternating and decreasing. Or I guess -1's the n over n is simpler. But if we only consider positive sequences, I guess, that can help me with my train of thought. I was thinking of making, like, a sub n minus epsilon is always less than L for any epsilon greater than 0. Well, epsilon isn't exactly 0, though. Well, I feel like intuitively I understand this. I don't know how you actually prove it, though. I'm thinking, like, if you were to rearrange this so that a sub n minus epsilon is less, or is less than L, which I know isn't quite. Well, let me just take this. That convergence implies bounded? Yes. That's what I mean, I think that's the conjecture that you're intended to make as part of question 7. Are we given a definition of bounded? I need to look back at the top of the page. I don't think we technically are, but we can make it kind of ugly to write formally. Oh wait, we do have a definition of bounded. Okay. Let me write some things out on the board. If you want to say your idea, Anders, please do. Implies bounded. So bounded, just writing down some relevant definitions. Absolute value of a sub n is less than k. For all n belongs to natural numbers. That's a horrible, weird n, but who cares? Then convergence. Limit as a sub n approaches L. Or, limit as n approaches infinity. I keep on writing the wrong thing. Okay. Just couple some things down on the board. Actually, let me read what Anders wrote first. We split the sequence in two. We have a finite and an infinite part. For the infinite part, we know that it is bounded since it is convergent. Well, we can just say it's bounded because it's convergent. That's what we're trying to prove. It's closer and closer to some point, which is the limit. The argument would be something like that, where you take a finite and an infinite part, which, I mean, that's an idea that we were talking about in a class last week, I think, too. With the definition of limit. Yeah, like that's what I was thinking that we should try and prove. So like what I want to do is somehow get from a sub n minus L is less than epsilon to a sub n is less than k. Which we could do some funky inequality stuff, I think. Everything is bounded by L plus epsilon. Something like that. But honestly, I wonder if we can just keep it simpler than that. Like, okay, so if I'm just allowed to ignore the absolute value bars for a minute here, just for the sake of demonstration, we can say a sub n minus L is less than epsilon, add L to each side, and say a sub n is less than epsilon plus L. Oh, actually, what I wanted to do is like insert just an L in the middle here, but we can't technically compare L and a sub n. We don't know that comparison is how they compare. But what I kind of want, or maybe we can say epsilon is negligible in some way, and just show that the limit is the bound. That's what I would like to do. Take max a1, a2, a sub n, L plus epsilon, define that as the upper bound. What could also be the minimum. Well, I guess we could split up minimum maximum cases. Call if you're still confused. Pick some epsilon at random. Huh. Okay, yeah, sure. If you just want to hop in Discord. Hey.
Hello. What's up?
Nothing much. How about you?
Nothing, just lurking in your stream
Yeah.
for the past 3 hours.
Well, thank you.
Sleeper, of course. What else? Wait, okay, let me.
Oh yeah, let me bring up your Discord.
All right. I need to set the scene, right?
Yeah.
Yeah.
Okay, got it.
Okay. So let's say we have a sequence on our beautiful line there. Okay. So this is our sequence, right? And the assumption is that it is convergent, right? Which means that like convergent to some number L. Let's see it right here, right? Which means that for every epsilon greater than 0 exists an n natural number such that if n is greater than n, then n minus L smaller than epsilon, right?
Great.
That's fine, okay. So let's say we have epsilon equal to 1. Just random number, it doesn't matter which one, just for simplicity,
Okay, yeah.
right? So if I watch the behavior of my sequence, like it will go like random. Wait, let me first hold the bounds here. Wait, I'm sloppy. L minus 1, L plus 1, right? So
You wrote
let's.
2, but yeah.
Oh yes, sorry. Mhm. No, it's red. Oh my god, technical issues. So this is our like sequence. Like it will start somewhere. We don't know there, and it will go around somewhere around the number line, right?
Mhm.
But then after like we reach the number n, like all of the terms will be like inside this interval here, right? Somewhere. Is that
Right.
fine? Okay, so what can we do then is like take, okay, let's say this is the first one, A1, this is A2, and so on until AN, call it like this.
Okay.
So we can take like the maximum of those numbers. Maximum, let's go here, of A1 or AN, right? And all of the rest will be bounded in this like interval. It won't get bigger than L plus 1. Or won't get lower than L minus 1.
Right.
So we can just take like what's the maximum of everything, right? So let's say L plus 1. So for any term, I can say that this is bigger equal to a k for any k. Is that fine? So that's pretty much the argument, right? Like that's the maximum, You can just list all of the guys that are inside, and with here you collect all the guys that are infinitely like outside, and that's how you collect all the terms and determine what's the maximum.
I guess it's pretty simple.
Yeah.
It was
Pretty
that
much
last
is
part that I didn't get.
yeah. Pretty much is the same with the lower bound. Just take the minimum of all these guys and L minus 1, right?
Hmm.
Yeah. Like sorry. a k for all k. Let's call it like this. That's pretty much the idea.
Okay, and partway through, I was getting confused at like, what if you have an alternating sequence? Like, is that really bounded? But our definition does say the absolute value, so we don't have to worry about that. Or this accounts for that.
Yeah, like the assumption that it converges, like. Yeah. Okay, I see what you mean. Like if it's.
Like, can you say it's bounded if it's alternating, but
n over one over n, right? Something
we're
like
only taking the
this.
positive part. Yeah, exactly.
So it'll go like this is 0, and it'll go like boom, 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 boom. Yeah, but it'll also be.
I think you need to just take the right half for our definition of bounded, at least. Like
Sorry,
the
what? I didn't.
I think you take the positive part for our definition of bounded because that has the absolute value. Unless I'm crazy, but it's the definition that Zach gave is a sequence is bounded by k if the absolute value of a sub n is less than k.
Okay, then let me just this.
So I assume we just deal with the right side of like your number line.
Yeah, I mean, like I just shown that there is a term that's bigger than everyone.
Yeah,
Of course,
yeah.
I can. If it's negative, of course, I can find positive one. So.
Okay.
Yeah. Okay. You're right. I think you should probably just take absolute values.
I guess then you wouldn't have to wait to a minimum maximum. I guess so. Yeah.
Yeah, I think that should work.
Okay.
Is that okay?
Yeah. Thank you for explaining that a bit more.
Yeah, no worries. I hope if anyone in chat has questions.
Yeah, zone range has an interesting other way to do it that I want to look at.
I think I did something on question 8. We can like do some couple of more till I go and. Actually, my internet's gonna cut off in 5 minutes though.
Oh no.
Like
okay. Do you want to keep on working for those 5 minutes or just not worry about it?
Sure, let's do it. Why not?
Okay.
I'll make myself some more tea. Fine.
Yes, Stuki. I felt like working on some more problems. And Bob hopped on.
Lessons start in like 2 hours for the other folks.
2 hours and 20 minutes, I think.
Oh yeah, okay. Well, you can pull up like the next question. We can work through it or something. I don't know.
Yeah.
Because I'm confused by the second question. Okay, I'll watch the stream actually.
Oh, I'll say I was still. Wait, what's the second question?
It's the 8th one, right?
Oh, 8.
Yeah, I don't know what's meant by 7th, other than already discussed.
Honestly, but before I even look at that, I want to look at what Zone Ranger put in chat. So I guess simply a different way to prove this.
Wait, what's the difference?
Using the reverse triangle inequality. I was kind of curious to try and understand it.
Guess. Is the Anders saying that or what?
Hey SVQ. No, I'll copy and paste it in chat again. In case you don't see it, but it's what Zone Ranger put. I guess Anders was also talking about it. But that part right there is what I was trying to like go through.
Yeah, pretty much said the same thing, I think, as I did, right?
Probably. Oh wait. What the hell?
I mean, that's pretty much this part.
Wait, it's like it gets like sandwiched.
Yeah, I mean.
Oh wait, no, I misread the initial thing.
Yeah.
It's like that. Two separate absolute values. Okay. That implies let's look like
I
a
mean,
so
I think
then
it's also important that we actually pick epsilon, because otherwise it's just too general, I think.
oh, it's important to actually pick the epsilon.
Yeah, I said like epsilon is 1 here, right? Applied it. You can
Oh
say
yeah, I guess
epsilon
you
is
didn't
any
have
number,
to.
but yeah, but you don't want to do, for all, because then the n is not well defined. It kind of gets a bit messy.
Oh, okay. So Zone Ranger did what I was trying to do with manipulating the actual letters. Okay, thank you for that, Zone Ranger. I couldn't figure out how to do that, and I would never thought of reverse triangle inequality. Okay. So yeah, it probably does amount to be a similar thing, but I was just curious to understand that logic. Because honestly, like if I know that trick, that would come to me easier. I think.
Mm-hmm.
But yeah,
Yeah,
if you
yeah.
want, we can move on to number 8.
Yeah, sure. Wait, let me just look up where it is. I mean,
Computation
like,
break.
yeah, the 8th one is kind of, different from all the things we were talking about right now. I remember this trick from like high school about doing those.
I remember seeing this in high school too. I don't remember how you deal with it.
Yeah. Like, I mean, first of all, you have to assume that the value exists, right?
Yeah, they do say convergent value, so I think we get to make that assumption.
Yeah. Yeah, sure. I remember there are like many ways to show this. I
Oh,
mean,
you set up. Oh, I think I know what you do. Or if you
yeah.
want, you can write it too. But
You want to do it, or should I?
or let's see. Let's both do it and see if we use the same trick. Maybe.
Sure.
Does it involve like saying it's equal to L and like you?
Yeah.
Okay, yeah. It'll be like root 12 plus L. So then L is equal to root 12 plus L is the trick. Sorry, I'll go on mute so I don't like distract you.
No, it's fine.
Okay. Oh yeah, you're beating me to it, but yeah, you get like quadratic.
Yeah. I watched enough of 3 blue, 1 brown. No. Sorry. Black pen, red pen.
Oh yeah. I love black pen, red pen.
Right.
For
Dude, you're
-3. Okay,
smart.
so we get the same
I
thing.
always do those. Dude, you're so smart. I always do the full formula.
I like
I don't know, man.
a lot of the Europeans I talk to just always do the quadratic formula, and that's crazy to me. It's so much easier to just do like the ABC thing.
Dude, I don't know. It's so hard for me to get it. To understand, like, how to quickly see, like, okay, I see that the multiplied give -12, or
Yeah, multiplies to -12, adds to -1.
yeah. No, that's the 1. See,
Uh,
it's always confusing.
no, it's -1. You don't have to flip it.
Wait, what? Wait, x1 is 4, x2 is -3. That's the 1.
Yeah, we get the same answer, but you take the positive one because it's square roots, right?
Yeah. Yeah, sure. Because you can get negatives in square roots.
Yeah.
I mean, you can do pretty much the same thing for all n, right? You just get x minus n.
Oh yeah. And then you
0,
do it in
and
your
then
precious formula.
Can you do now?
No.
No?
Unfortunately.
1 plus n over 2, which will give us pretty much just a positive one, right?
Yeah.
There we go.
Okay. And then we have to do the same thing, but with multiplication instead of addition now.
God damn it. Zach, why?
I think it's going to be simpler to factor. So I don't know, I want to do it for myself just so I can like get used to it, but you can do it too if you want or not. It's up to you. Because I never knew this trick until like a couple of days ago. Oh, okay, you just get 12, or you get 0. I don't know how you. Well, it certainly can't be 0. Well, no, it's not. I can't imagine it's to be 0.
Am I back?
Oh, I can hear you now.
Yeah, the internet died right on schedule.
Oh, but it came back.
Yeah.
I thought it would be like permanently, or not like permanently dead, but for a while.
No. I'm not in Korea, bro.
Wait, did we do something different here? I don't get 1 over.
Right. Oh, wait, there it is, X. Wait.
Oh, wait, you're just doing a different way.
So it's either
Okay, X
n
equals M. Okay, yeah, and I got 12.
Wait. For any n bigger than.
Oh, I didn't even do the generalized part. I forgot about that.
Yeah, I just
that,
did the general.
that you did that. Okay.
The original one. So X can't be 0, right?
No, it's greater than 0. Oh, and that's how you justify getting rid of the 0.
Like I get 2x solutions, right? But why is 0 not valid?
And it's because of what you said. We're given generalized by replacing 12 by any n greater than 0. So this can't possibly be equal to 0, I don't think.
Yeah. Oh, right. Because like if you give enough square roots, you will get. Wait. Yeah, if the number is small, then it would go greater. But I don't. Yeah, I think it can be 0, but not still sure why not. Otherwise, just n. Yeah.
Okay.
The 9th one actually looks kind of.
Yeah, we got kappas. It's like a binary search, where you chop off half each time.
All right. Oh, right. You're a genius, man. Oh, yeah. It goes into the K2, right?
So, yeah, it should converge to the midpoint. K1, K2?
No, I think I should go to the bigger one of the two guys.
Oh, does it? I guess let's
Yeah,
try
like binary
some
search.
values. Sorry, what?
Yeah, let me try that also. If only I knew Excel like Danny. think it goes to the bigger one. Does it? Right.
Oh, you're right.
No, it doesn't.
Or
Where does it go, bro?
okay, you know, I'm trying on the board too. Actually, I was being lazy and letting you do it for me. But I just want to try with like 1 and 2 or something for your initials.
Yeah, I picked 0 and 1.
They have to be greater than 0 according to the original
I got
prompt. Well, I mean, it's part C is like to generalize it for any kappas, but
Yeah.
so it's still good to know that. But
But the next one will go here, then here, then here. Some Fibonacci pull. Yeah. It does smell like a bit of Fibonacci with the.
yeah,
Oh, shall we do the trick from I think the last prompt? If you did it. Like, let's assume it converges,
oh,
and
it
then
does
go
seem like it should converge. I think we're gonna have to do it.
L plus L over 2. I don't. You can get L equals L.
Oh well, and that's good to know too.
Okay. God damn it. We got bamboozled.
Oh yeah, you do get L equals L.
Wait. Wait. I remember this trick. I remember the trick. I don't remember why it works. So that's kind of suboptimal.
Yeah, what the heck? Okay, so I with 1 and 2, it's somewhere between 1 and 2. I just don't know what the actual value is converging to with my example.
Mhm. So you just use this. Cool. Oh boy. Can I solve this even?
I wonder if it is. Oh my god. Okay, Wolfram Alpha has a recursive sequence calculator, I think.
Oh, there's a calculator for it. I remember like just this technique for finding the.
Yeah.
So these are the two converging
Oh, but
values.
it's only for one initial value. You can't do like two different.
Yeah, I guess there's some bound for it. I don't know. This is interesting. I don't know how to. I don't really know.
It might be the 3/4 point, I wonder.
Wait, are there initial values greater than 0? Yeah. Okay.
3, 865.
Yeah. Why does it feel like it's always converging to some random thingy?
I don't know. This is weird.
Like I feel like hear me out. If I have some line, let's say this is 1 or 2,
Okay.
and it will converge, let's say somewhere around here. I have a feeling like if you scale it up, let's say I studied big different solutions, 1 over, let's say, 100, like it will fall pretty much in the same spot.
Yeah.
Because it is kind of a, binary search, as you said. You go here, and then you go here, and then you go here, and then you go here. And, somewhere along those lines. So, I'm thinking, like, it will always be, like, in the same ratio, somewhat. Depending if it's on the left, which is the first number, and so on, but it's hard to find the ratio.
So, I don't know, when I was just trying with 1 and 2, I'm getting about 1 2/3, but I'm also wondering if it could be the golden ratio, because that's like 1.61. I'm getting more like 1.66, but it might just be like the 2/3 mark between the two values. I don't know how you prove that, though.
I have no idea. Zach is wild for giving us to prove this. What the hell? No idea. But it feels like, it smells so Fibonacci that it's got to do something with golden ratios.
There is, like, if you take the average of two Fibonacci numbers, I think that is something special, isn't it? Let me see.
Oh, that's the part of combinatorics that I don't remember. All the identities for.
Yeah. Oh wait, it is just Fibonacci divided by 2.
Yeah.
I don't know why I didn't put that together earlier.
Wait, it doesn't like launch into the infinity. It goes smaller and smaller. To always be in the
Oh, but you
middle
divide
of
it by 2 each time. Okay, so it's not exactly, it's not simple. It's just, okay, yeah.
God damn it, I'm pulling up C++. I'm a cheater and I don't, I'm not ashamed of it.
You don't do real math.
Yeah, since we do recursions on analysis.
Oh, yeah, Jeff, I'm in Discord call with
Shall I use
Bob right
float or
now.
double? I'm gonna use double.
I'm doing the real analysis stuff right now. Sorry, what?
Sorry, I'm thinking out loud.
Oh, no worries. How do you, like, Fibonacci, like, golden ratio proof? Classic non-trivial problem. This video just an average recursion, or is it? Oh, is it gonna actually, like, do the problem for me, though? I might want to look at it. Like, I want to see if I can find just the technique without being given the actual answer. Okay, do it as a limit like that? Oh, the ratio of successive Fibonacci numbers converges to the golden ratio. But I guess that's not what we want. We want the actual terms, don't we? So don't like spoil it, Jeff, if you already know the answer, but this is the problem that we're working on right now. I did some test values with kappa 1 equals 1, kappa 2 equals 2. And it seemed to go to about 1 2/3. Maybe I need to try different initial values. I think Bob might be doing that too.
Oh,
Do you know the answer? So you average the previous two terms? Exactly, yeah. So it seems like a binary search to me. But maybe you're always just taking the upper half. Can we see if I can find that video and just like have it open in the background? I don't know if I want to like look at it yet if it's going to spoil things. Okay, yeah, so I'll have this open for later. And if anyone wants to see it for themselves, that's the video there, it looks like. And thanks for calling that out, Zone Ranger.
Oh, yeah.
I don't want to draw this out, maybe. Maybe if I visualize it, I'll get somewhere. Because to me, it almost makes more sense that it would go to the 1 3/4 mark rather than the 1 2/3 mark. Let's call that kappa sub 1, that kappa sub 2. Kappa sub 3 is smack in the middle. And then we go smack in the middle of those two, kappa sub 4. Smack in the middle of these two. I guess that's why it's not 1 3/4, because we actually hit the 1 3/4 mark. Kappa sub 5. Kappa sub 6. Okay, so that does help me.
You pretty much made a code. And
wrap my head around it being the 1 2/3 mark. I couldn't tell you why exactly right now.
somewhere weird. Getting like, wait, are we here?
Yeah.
Yeah, okay. So I should actually just stream Visual Studio so you can see what I do. Change the scene. There we go. Can you see?
Yes.
Okay, so if I call it, let's say our starting point is 1. These are first two numbers, and let's say for 10 repeats, you know, you get this.
Okay.
So goes to 1.66666666. I can actually make more repeats, so let's say 30. Yeah, it like
Okay.
settles around 1.66666.
That's interesting.
Yeah. So what is that?
So I kind of like I drew a number line and I just took two generic like starting points and I just kept going halfway between them. And visually, that 2/3 mark I think is right.
Yeah, 2/3 mark, yeah.
I'm trying to figure out like how we can use that. Like, could we do that same kind of recursion trick, but we set the sequence equal to like 2/3 kappa sub 2? And say that kappa sub n minus 1 is equal to kappa sub n minus 2 or something? Or maybe they're all just 2/3 kappa sub 2.
It feels like this is what it approaches, right?
Not sure. Oh, did you go back
I'm
to
not-
the so right now your
Oh,
screen
yeah,
share is
yeah,
still on the
I
okay.
need to. I'll just share the screen. That would be easier.
So as long as you're I'm like showing it on Twitch, so as long as you're not going to show something that you don't want to.
Yeah, something you don't want.
Yeah.
Gonna get you banned.
Okay.
Wait, can I actually make it more clear? Oh, sorry. No, that doesn't. That won't work. Well, whatever. Crap, that's not what I meant. Never mind. Okay. So I think like that could be like a formula. Along those lines, like 2/3 of this guy. I'll just test it a bit.
Okay.
Would be a good guess. Let's say what would be perfect? If it's between 1 and 4, it should go to 3, right?
Yes. Okay, yeah. Oh. Okay.
That works. How do we prove it?
That is the question, isn't it? Like, if we took in the same way that we like we took the original formula, we said that's like equal to L. Like, could we just say that 2/3 kappa sub 2 is our L? I don't know if we're going to get kappa sub 2 equals kappa sub 2, but that's the only idea that
Yeah,
I can think of.
I mean that would be our L, right?
Yeah. I guess I'm going to see if we just get something redundant, but it's the only thing that I can think of right now.
Why is that so weird?
Well, wait, that's just no, never mind. It's redundant.
I think I'm gonna go make myself some tea. So when I come
Okay.
back, you know, maybe first take on the problem.
Sounds good.
I'll be back.
All right. See you in a bit. So I do have the video opened here. Oh, what's new? Oh, my short went live. Okay. Hey, people are commenting on it. That's good. So yeah, I have the video up here, but I don't want to spoil it quite yet. So I'm gonna watch it. So I've hopefully figured it out. So if we're already pretty sure that it approaches 2/3 times kappa sub 2, how does this behave for large values of n, I guess? Kappa sub n plus 1 and kappa sub n are getting very close together. Hmm. I don't know. I'm if visual proofs were adequate, I would just say it's the number line that I drew on the board. Obviously, they're not adequate. And I'm trying to think of a way that I can put that visual into words right now. After our first iteration, like we're in the upper half of the interval between kappa 1 and kappa 2. In the second iteration, we're in like the 50% to 75% range. And there's a narrowing down that happens. Is this a geometric sequence with 1 over, like, it was a over 1 minus r? Could you say that it's... Because what we're really doing is cutting it in half every single time. And so if you have... Well, you're not adding them, are you? It feels like the situation if you just start with the number 1 and cut it in half and many times. So 1 times 1/2 to the n. And I want to apply the formula a over 1 minus r, but that actually doesn't get you to 2/3. So maybe that's not right. Yeah, sure, Jeff. If it's something that, like, you're thinking... Oh, OBIS. Shoot, you know, I should have been more specific. You do that using Mathematica? You try writing out a formula for the nth term and proving it. Hmm. Yes, BQ, it should be 2/3 of K2. Hey, Spetri, thanks so much for the 9 months. Get yourself something nice to drink for that hard math you did. It's not even done. I do have some nice water. Thank you, though, Spetri. I really appreciate that. But yeah, I don't like go to oh yeah, yes, because that feels like or like that's a little bit like too much for that I don't want to do right now. Just try to improve
Okay,
it.
I'm back.
Hey.
So, okay, I got an idea while I was making tea. Like
Okay.
some sort of. Like, where is the prompt? What if we try to use like oh, that's not what I wanted. There. So what if we try to use like something like from the prompt 8, like that idea?
So that's what
Being like,
we were trying. We kept getting like redundant things.
okay, maybe I had an idea which is not good. Never mind. So I was like thinking like substituting here some things and trying to get what to the A1 somehow. So like that would be like a n plus a n minus 1
Hey
over
Enigma,
2 plus a n
we're working on the real
over
analysis stuff
2.
that Bob and I were doing this morning. So there's
So what if we try
potential
to
spoilers. We're working on number 9.
the nt
I just wanted to warn you about that.
over
But I hope you're doing good.
wait, sorry. 2n minus 1. So that would be 4.
Okay, yeah. So
Right.
this is well, while you're on, Jeff and SPQ were saying something like this, like trying to get the formula in terms of or write a formula for the nth term.
Yeah.
Yes, sorry, Enigma. You're welcome to say if you want, but I don't want you to spoil it. Or I don't want to
So
spoil
like
you
I
if you
think
don't want to
like
be
we kind of
spoiled. But
decreased our numbers here, right?
we're later
We go
on,
from
so
n plus
it's
1
up
and
to
n
you.
to n and minus 1 and try to get to you know to the first terms. Well, that gave maybe that will give us some insight. Sorry, 4. 5.
There's clearly a 3/2 somewhere inside there, so I think we've proven it. Job done.
Yeah, we got 3 over 4 here. QED.
Yeah.
I feel like we're getting somewhere, but I'm just trying to figure out the pattern, you know?
Yeah, same. I think this is the right track.
Oh no, that doesn't look good. What am I doing? I feel like some induction thing might come in handy.
Maybe.
5. So let's just do one more turn to see if this makes sense. That's 3. Plus equals to 8 and minus 3. Sorry, 2 for 8. This shall give us like 7. 8 and minus 2 plus 8 and 3 over 16. So I see that this goes up by the powers of 2. And this
Yes.
goes by like the odd numbers. And that's all the
Okay.
chain, right? So I was thinking that maybe we can prove by induction that AN would be, oh god. I don't have brain power for this. Let's see.
I'm running out of brain power too. So I'm glad that you're the one who's doing the writing.
Yeah. Where's the prompt? There it is. Okay.
Yeah, we're working backwards, Jeff. So I'm not sure exactly where it's going to go like this.
Give us like AN. Plus 2. Is it 2 minus 1? AN plus 1. Wait. No, sorry. A1. A0 over 2 to the power of what? Minus 1. I think that's the claim.
Yeah, I was wondering if like we would get something like power of 2m. Actually, it wouldn't be 2m minus 1. Or it wouldn't be a power of it.
I mean, we're getting the power of 2, but this is just going 3, 5, 7. Like, okay, so the base case would be, it's gonna do it wonky because I'm lazy. A2 is equal to, if we plug in n is equal to, sorry.
We need to choose an A0 and A1, I guess. Or do we?
Wait, I think this is wrong. So n is equal to 0. Why are we doing it with 0 and 1? Sorry, it's 1, it's 2 and 1. There we go.
Oh, okay, Jeff.
Hey. I think that might be good. To be 3. Oh my god, I'm doing stupid stuff. It's not even.
If it makes you feel any better, you're doing way better than I would be.
Wait. Let me just. I'm trying to, form it by the base case. See.
Yeah,
How
because I'm
it
not sure
would.
the like indices matching.
So n is 1. That would work. N is 1. Yeah, I think that's fine. Yeah, okay. So base case n is equal to 1. We got it A3 is equal to A2 plus A1 over 2. Right. So let's say for
Oh, okay. I see.
if it works for some k from n, that ak plus 2 is equal to 2 over 2k minus 1 over a2 plus a1. Maybe I'll need Stuki to explain induction to me. There we go. Then
Okay.
maybe for a3, ak plus 3, right? I want this. 2k minus 1, sorry, plus 1, a2 plus a1 over 2k plus 1. That's what I want.
Right.
So I have this ak plus 3. Let's just call it solve, like solution. Would be ak plus 2 plus ak plus 1. Oh, that actually works for pairs, right? For the ak plus 1 is also this, but this. It's like some sort of, yeah.
Would we need that? I guess it doesn't hurt.
I want to transform these two guys here.
Oh,
right?
yeah, we do need to transform them both. You're right.
So much work. God damn it, Zach. Oh, this will be rough. So there's 2. Let's do this. 2k minus 1 a2 plus a1. Oh my god. I'm already scared. Especially because I don't know if it's gonna work.
Jeff did just work ahead, and he said that we might have done something slightly wrong.
We might have, yeah.
Or well, you. Sorry, I've been contributing. I know.
I might have definitely done something wrong. Right, okay, so let's... This 2, right? So this will be
Jeff, if you want to post it, sure.
a2 times 2k minus 1 plus 4k minus 6. Oh, no, this doesn't look good. 2k plus 1. Am I doing this right? Multiply this by 2 to get under the same thingy. Oh no. I think something's going wrong.
7. Oh yeah, I'm not sure where this is going.
Yeah. This is not good.
Okay, so I think the pattern is.
Yeah,
What were we doing wrong? Or sorry, you. Or
yeah.
Jeff posting what the pattern should be in chat right now.
That does not work. At least I got my tea.
And Endolib? Thanks for the follow. I'm probably saying that wrong.
Still does not help us, but you know.
Assuming Jeff's calculations are right. Okay, so I guess the extension is like, are we going to eventually take k approaches infinity and then hopefully get 2/3 a2?
That will not work, I think.
That I assume that's the end goal here.
Yeah. Like you wanted to approach. I mean, we're still in the induction. We haven't proved that this
Yeah.
is.
So we haven't gotten to that stage yet, but I guess. It's annoying, and I'm kind of like running out of brain power, but
My
yeah,
excuse is that
there's more math
I'm
streamers
sick.
than just me. I do homework help, and right now I'm doing a little
don't know
bit
what
of
you
like
got.
studying with No Pro Bob. Sorry, what?
My excuse is that I'm sick. I don't know what you got.
Oh, my excuse is that you started to do the work for me, and so I got lazy.
Oh yeah, right.
That's my excuse. It's not a very good one, but I'm using it. I'm kind of at the point where I just want to like put a pin in this and like come back to it with a fresher mind. So I think your
Yeah.
idea here is right. Maybe I kind of want to try getting the pattern for myself too, and then like maybe train these same steps.
Yeah, I mean,
Because I think these are the right steps. I'm just having a hard time actually like following it right now. Oh, well, you're in luck because Eats the 2i Pie, who's in that list, is actually doing a live real analysis class on Twitch.
oh my God. I see.
This is the second week of it, so it's not too late to get caught up. And the next one is going to start in an hour and a half.
Look at this.
And sorry, I don't mean to like you come on the stream and I mean to start like
Man.
selling you on things, but welcome in. And there's no pressure to actually do anything. But when someone says that they're new and interested in math streamers, I like to give a plug to the other people in the community.
Start learning my ring theory again.
So I tend to do homework help, and then right now it's like a little bit of like studying in math for fun. Oh yeah, so Jeff was saying that we should have a coefficient over there. I was having a hard time seeing the pattern.
Yeah, I didn't distribute. Everything's wrong. I'm just.
Okay.
Yeah, everything goes to waste.
You would check it out. I mean, I don't. The error early on sucks, but I think the idea is good.
Wait, what if I do it like that then?
You'll check it out.
Now I'm
Awesome.
afraid of doing
It's no
arithmetics.
pressure at all. I'm probably not gonna be on this Discord call for a ton. Actually, if you were to join Zach's Discord, and if you want to get involved in it, and I know that you don't have to commit to anything right now.
Do get Fibonacci.
Over in his Discord, just go to broadcast announcements and scroll up until you see this one. Wow, there's a lot of people have reacted and react to one of these two messages.
You actually get Fibonacci.
And you'll get more like notifications and things about it, and you'll see like the problem sets.
Fibonacci, no!
It seems Fibonacci-like. From what Jeff posted, it wasn't. It seemed like it skipped some, or something.
Yeah, you get here minus 2 plus 5.
So yeah, do
3.
Whatever you want. I don't mean to try and sell you on everything, but I just figured
like every time
something that you're interested
this
in.
guy
And no worries at all if not.
into the second term.
Dude, how do I make this big?
Wait, no. Maybe I'm tripping again. I think I'm tripping
Oh, there we
again. Don't get sick and drive. Or sick and drive, or whatever the term is.
So I can. This is what Jeff got. It should be like.
No, maybe this Fibonacci, right?
1 a sub 1, 3k sub 2, 3k sub 1, 5k sub 2, 5k sub 1, or A's, 11k sub 2, 11k sub 1, 21k sub 2. But I'm having a hard time doing things right now.
Let's go Fibonacci. How do you define Fibonacci's, right? F1.
Or F and, or okay.
Right. Well, let me just list them.
Yeah,
just in where we go. 1, 2, 3, 4, 5, right? 1, 1, 2. Or people start with 0, but it doesn't matter here. 3, 5.
Yeah.
8. Okay, there we go. I think that should be enough for us. So I think an plus 2 would be some Fibonacci thingy. Of course, 2 to the power of n. Let me see if I'm not stupid again. I'm so scared at this point. But I am stupid, what? Oh no.
I mean, I can try and work this out on my board too. It'd only be fair, I guess.
Yeah, I'll give this to you, man. Give me this.
That's fair. All right.
There we go. I'm watching you on the other screen, so there's no infinite loopings.
Okay. Don, you use some computer algebra programs, right? Depends what you mean by computer algebra problem, I think.
I've seen your board, and I'm curious. Does this work? Nah. I mean, yeah, but
Mathematica, but not quite. Not really. I've learned like MATLAB, or unless you want to count like Wolfram Alpha, but it's not really like Mathematica. I don't think I know any that are like that. K sub n plus 2 is equal to k sub n plus 1 plus k sub n over 2. So what we were doing is we were subbing on k sub n plus 1.
it would be actually so much easier if we just write that kn is equal to kn minus 1 plus kn minus 2, I think.
Actually, Jeff also mentioned like trying to work forwards instead, which might be easier.
Yeah.
Because we're kind of doing it backwards.
Like one of the techniques all recursions are to solve it backwards, but
When it's like, wait, what?
wait, if it's 0, you just get 0 always. Oh, sorry, greater than 0. Oh.
Oh yeah, it's a messy greater than. And then on that case of 3, we can... Because this might be a bit clear, like, where the indices actually are. I was getting a bit lost when I was looking at your work. Oh, it's also because my own tired brain. Three case of 2?
Yeah.
Okay. Okay. So 2 over 2 plus case of 1 plus case of 2 over 2 over 2.
Oh, interesting.
Oh, sorry, what? I'm talking to myself as I do like mental math. That's not right. Okay, yeah, someone buzzed me. Jed
That
did.
does not look correct. Wait, actually. Maybe.
Oh, Endel? I'm sorry, I'm probably still saying that wrong, but yeah, you should absolutely check out Zach's course in that case. I think it'll be right up your alley. Case of 4. Oh, thank you, Jed.
Oh, yeah, there we go.
Okay, so that gets multiplied by 2. So you get 3 k sub 1. Plus 5 k sub 2. I think this is matching what Jeff was getting to. 5 k sub 1 plus 11 k sub 2 over 16. Okay, yeah, so the bottom are still powers of 2, and then we get a weird, almost Fibonacci, but not quite. Because we should have an 8 in here if it was Fibonacci.
Yeah.
Exactly.
What the hell are there? What are those?
I don't know. I'll do one more just see if it helps, and then I'll. Actually, Jeff, I think, looked it up in OES and it doesn't have a name. But it was something that I had heard. Five plus 8. No. 5 plus 6 is 11. 11 plus 10 is 21.
Dude,
32.
Oh my god, dude. Okay, this. Yeah, that kind of gets weird, but look at this, what I have in mind now.
Oh, on your Discord, let me. Yep.
Yeah, if I'm streaming still.
Yeah, I see it.
So just a genius idea bumped into my head.
Okay.
I don't know if it works, but let's say we have an interval from 0 to 1, right? So A1 is equal to 0, A2 is equal to 1, right? So what's going on? First, you're gonna go from the left to the middle, right? So
Right.
1/2. Then you go from the right to the middle of that new section, right?
Mm-hmm.
So you get 1/4. Then you go from the left to the middle again.
Well,
so
1/4 or 3/4.
yeah, so like here with this 3/4.
Or
So
that's similar.
then from the right here, then here, you know. So I was thinking, like, by how much does the interval shrink every time?
Well,
Let's
by
say
like 1/2
this,
to the n.
yeah, like 1/n, right? So I can say like this will be equal to kinda.
Or it's
Oh wait,
just
that doesn't work.
1/2.
Oh my god, I had an idea. No, it doesn't work. I thought
I was
we were gonna
trying to
get
do
some
something like that. It feels like it's
up-
geometric or something.
yeah, I tried to do something like this, you know?
Oh,
And then maybe ah, but that does get us a
I didn't think about
third, I
making it
think.
alternating.
I think that does get us a third. Right? Because A1 is
SPQ
let's
is
say
saying this is how they approached it.
Q equals minus 1/2, right? So the sum is A1 over 1 minus Q, which would be what would it be? Am I stupid? I'm stupid. I'm my brain is dead right now. Wait, and that would give us 3/4, right? Wait, am I doing this?
Could be 3/4, but
No, 4 threes. That would guess. No, wait. What am I doing?
we're expecting 2/3.
I'm doing everything step by step so I don't mess anything up.
Hey,
Hello.
Oh, hey.
So it's
yeah,
6
I wonder
over
where is the question? Yeah, I want to see it.
4 over 6, which will give us the thirds.
Oh, you do get 2/3.
QED.
Oh my god, that's a lot simpler. If it's alternating, does that formula still apply? Oh yeah, because the rate is negative. Okay. Wow, that's
but
way
no,
easier.
No, that doesn't even work. It
It
shouldn't
doesn't?
work. Like, I'm just looking at here because, like, I get 1/2 and then I go
Actually, it wouldn't be minus
backwards.
a quarter, would it? Yeah. It should be plus
Yeah.
or not minus. I don't know.
Does the question say the series converge or the sequence converge?
Sequence.
The sequence, yeah.
Okay, cause could we solve like the homogeneous, like try to get its functions and try to plug in very big numbers, and it will
Yeah, I did
finally
it
like
already.
use.
Yeah, don't worry. Look here.
Uh,
Here is some my programming cheating scandal. Thing. And we kind of got that it got there, but this is pure math. We need proofs.
yeah, because I tried like assuming like there's some constants that it's increasing with it, then I make it a quadratic, then you solve the quadratic and get solutions and construct it as exponents, then try to log in very big n, then it will see it's converge to 0.
Wait, really?
Yeah.
Right now I'm questioning myself. Where did I get 4 from? I can do algebra, man. Yeah, this will go to 1/3 actually. Yeah, there we go. Uh, 1 2/6 with 1/3. There we go. Now it would make sense to go here.
Is it 1/3?
Sorry, what?
Or aren't we expecting 2/3?
Yeah, we are, but like the series is kind of weird. That was the problem when I started explaining it and figured out like first you get 1/2, right? So what this series would do is go 2/2, then subtract itself, then continue. Like here, right? It's kind of similar to what we're doing, right? Just to the other side.
I guess so, yeah.
I
I
have
guess
no
this would be
formula.
like, would this be if we had like K2 minus K1 for in the lower half? Like, maybe it's just a question of having a different initial term. Like you have 1 minus 1/2 plus a quarter minus an eighth.
Oh. Hmm.
And with that, the new formula would be 1 over 1 plus a half,
Wait,
or
so you mean
no?
like wait, so you mean like add this? Or wait, I'm not sure about you. Like the different alternative maybe? Is that what you meant?
Yeah, like having a slightly different
Oh,
starting
right.
point to make it actually match the situation. Because I think you can get 2/3 with this.
Yeah, so like what if we do you're right, we can do this. That would make more sense. There we go. Now it should work,
Yeah.
right? Yeah. We got from 1, then we go there, then we go up. Yeah, okay. Then it should give us something good. This become 1. There we go.
But the problem is right there. Sorry, it was being
Yeah.
covered up.
Hurts. Everything. Nice, Don. Nice.
I actually contributed something after watching you do math for like an hour.
Well, that's just like watching someone being tortured by doing this arithmetic. So, but we have so much work to do if you want to prove anything.
Oh, I'm sure. I was trying to work that out while you were getting food, because I did that same like number line thing, but I felt like there's geometric sequence involved, but I couldn't attach the numbers like that to it, so I gave up.
What you used when with the program, when you used the homogeneous, why it doesn't work?
What program? What?
You said like you used that the idea that I was talking about, which
Oh,
is
I coded it myself on C++.
oh no, I'm talking about like assume that an is equal to lambda to the power of n, then convert it to being solving a homogeneous system, then you convert it from a sequence to like a function, then it
Yeah.
approach infinity, then you get me?
Yeah. I said that I used that, but I forgot how it's used and why it's used. Wait, maybe I have it somewhere here.
Look, it's
I got like -2 and 1, -1/2 and 1, which gave me
yeah,
nothing.
It-
It's
yeah.
obviously incorrect.
Mate if n equal some constant 1 equal that half negative half to the power of n plus some other constant to 1 to the power of n, because it's just 1,
Oh, right.
but you
I think I remember like this to the n
yeah.
plus to the
There's
n,
constant
and then you like use
because
like A and
there
B,
there's
and then you
linear
solve.
percentage linear percentage between the
Oh,
two
right.
roots you have.
Yeah, forgot
Then
about that, right? And then you solve
well
for B and
one
A, and that's the solution.
let m approach infinity, which m is just n, you know.
Oh,
Yeah,
I mean,
a and b is related to what values of k1 or k2 you will decide to be to
We've
start
been
with,
stuck
you know.
on
A and b will change on that,
uh,
but actually
basically A and
it
B
doesn't matter,
for a
because
while
when you
now.
plug in very big m,
We
it
haven't even
will
thought about
converge
part
to
C yet.
some zeros that will converge to the constant a that you
So I think we just got
for
something that's
just a
pretty
function.
proof-like,
sure.
but probably
I
not
could share
as
screen
rigorous as it could be.
with the whiteboard.
So here's what I'm thinking. Like, okay,
Yeah.
so if we do it like this,
And if you
let's
already
say,
know the answer, then
like I can just make an
we're asking for
implicit
for
formula
no spoilers,
or
but
explicit. Which one is it?
hints that don't give it away are
For A
okay.
and B.
Oh yeah, I got you.
Yeah. So
And if you don't know the answer, then feel free to
for n
discuss.
equals 1.
But you need
you know,
initial values for the sequence. You have
Yeah,
to.
yeah. I'll just add it, write it
Okay.
as K1. You know. So that'd be
Okay.
minus bagel 2 plus A equals K1. And then for n equals 2, what, B over 4 plus A will be equal to K2. These are our initial values, right?
Kappa. Yeah, I mean that pretty much is
Okay,
it.
so now we, I don't know, multiply by -1, solve the system. We get B over 2, 3B.
I'm kind of lost with where they got the
over 4
b times -1/2 to the m
equal
plus
to
1 to the, or the not n, the n, a
K1.
plus kn.
And if you just plug it
I don't want to interrupt the train of
into
thought.
the system, we get.
Actually,
Sorry.
we need
So
the
I don't know,
A, not the
Wood, if
B.
you're this close.
what?
Yeah, so
Make it
Oh,
again.
yeah,
Make,
okay. Later
I just think
we
characters
can
equation part, I
take
just
A also after this from the
you
system.
know what? Why I want to make it from
Because
A?
it will go
Because
to
when
infinity,
it's
like when
that line
Yeah,
right there
yeah,
that I don't get.
right?
got it.
Yeah, I get it. I just want to solve the system so we can have the formula
Everything
to
else, I
work.
think I understand.
Okay, and then just let's plug it in here. So let's minus 2/3 of K2 minus K1 plus A equals K1. Oh, god damn it. So minus 2 over 3 K2 plus 2K plus A is equal to K1. Let's plug this guy in. Minus 2/3 K2. That is right. Maybe, I don't know.
Actually, A is equal to K1 plus K2 over 3. A is equal to K1 plus K2 over 3. Yeah.
Mhm.
If you want to follow
Yeah,
the
yeah,
steps,
yeah.
let's
Wait, let me just. Sorry, I got distracted.
okay.
Oh, I didn't know that, Jeff.
I
Okay.
got something weird then, maybe.
Thank you for telling me that.
K1. So wait, I got K1
I have very little experience with like
plus 2K2 over
recursive
2
sequences like this.
over 3. Then I got something wrong. Wait, I said this is 4. Okay, divided by
I done it differently. Like the equation up here was for K1. I made it twice. Then I sum it with the under one was K2, and
What?
will
Oh.
cancel out easily.
Oh, yeah. Wait, no, but this will also get me the same because if I just multiply this by 2,
Yeah,
sorry, by
it should
2,
get you the same result.
and add it here, then I get that A will be,
3A equal.
2A will be 2, these guys, and it'll be the same. Maybe I did this wrong? I don't know.
Then it should, even any initial value, it will convert to K1 plus K2 over 3. Yeah.
But yeah, still this doesn't. Wait,
I don't know
is
either
it actually like
who it is. I was
fine?
kind of taking that as
Yeah.
fact, but I don't know
I
why
think
it
that
would
would
work.
actually work for our
It feels
case.
weird.
Like as n goes to
That's something where I
infinity.
just trust the people smarter than me. I figured it out.
Sorry.
Are you sure
Let's-
it's 2K2?
Yeah, that would work. That would work. Like, so our
Yeah,
explicit
Try.
function would be an is oh god damn it. -1 over 2. Where was it? Where was it? -1 over 2 to the power of n times, what was it, b? Sorry, b. Where did I get b? This. Times 4/3. Like, still, even as I'm doing this, I really don't think this is, meant to be that's how we meant to solve the problem in analysis course. This is like
But it's
pure
easier.
discrete mathematics.
Yeah,
Plus
we need.
K1, 2K2.
For that reason, I wanted to start with real analysis because, yeah, I know how to do it, but I want to know why it's working.
Times 1, like equals to, yeah, that's it. That would be like our formula, I think. So as n approaches
Yeah.
infinity, this would go to like this would go to 0, right? Because of this n guy. And we'll be left with this, but does this coincide with what we were talking about?
Well,
So
it
if
is. Uh,
K1 is equal to 1, K2 is equal to 2, right? And we would want 1.666, so on, right? And we would get infinity 1 plus 2 times 2 over 3, which will give us not good.
what we want. Yeah.
5/3, yeah,
Yeah.
that's 1.666. There you go.
Oh,
So I guess that's it. Doing by
easy.
discrete way of homogenic stuff, but yeah. I'm pretty sure Zach like didn't meant for it to be solved like that, but still.
Yeah, I'm sure there's even another way entirely. Like the way that we were going to trying to find the pattern is probably also possible.
I'm pretty sure Zach is just an evil guy who wants to break the
I do like that geometric way.
Yeah, I like it too. We just need to,
It's probably not.
generalize it for A1
Yeah.
and A2.
I'm wondering, have you tried it to make it like a continuous fraction type of thing?
Yeah, we
And
tried
then,
doing that, but got nowhere.
yeah. Okay.
I'm gonna be honest, guys. I'm getting kind of mathed out. So, all
Yeah, I think that's enough for today.
right. Well, thanks, Bob, for hanging out with me for doing the heavy lifting.
That's because I was today Scribble Master, right?
Yeah, exactly.
God damn it.
I'm the leader, so I'd order you to do
Well
the
by
problems for me.
Thursday. Hope I get well by Thursday so you can be the Scribble Master.
Yeah. Hope you get well too.
Then you'd have to do all the arithmetics. Yeah. Anyways, I'm done, so I'm gonna lurk in your stream if I'm meaning to stream. If not,
Okay. Yeah. SPQ is gonna share another solution. It sounds like, and SPQ, feel free to put it in there.
yeah.
And Endlib, or can you pronounce your name for me, or how I should call you?
My name is actually Mina, but
Mina?
this,
Oh,
yeah, this is just a nickname. It's Andalib. Sri
Andalib?
is just like it is like letter we don't have in Arabic. I'm Egyptian actually.
Oh, okay.
Or Sri is like it isn't in English for that I write it like a Sri. But I'm
Oh,
Mina.
okay.
Call me
I'll
Mina.
just remember Mina. It's easier.
Yeah.
It's good to meet you. I'm gonna be hanging out in the stream a bit more, but I'm probably gonna switch away from math in a minute.
Yeah.
Goodbye.
All right, bye.
Bye.
Okay. Okay. So yeah, SPQ, feel free to put your solution in there. Because I guess I feel like we've now found two different ones, so I think it's an okay time to avoid awkwardness. I think it's with the couchy sequences. No. I don't know if that's coming or not. X of n plus 2 is equal to x2 plus x2 minus x1. Times the sum negative 1 to the k over 2 to the k for k equals 1 to n. One third times 1 plus 2/3 times 2. Oh, 1/3 x1 plus, yeah, okay. Sometimes Twitch is super weird. And also my eyes are super weird, especially after I've been doing math for 4.5 hours. I didn't mean to do math for this long, but these questions have been kind of fun. I'll try the link too, Jeff, but let's see if what it tells me. Oh, yeah. So I'm not really following that SPQ still, or I guess what that's happening, but I'm also kind of not at my like peak mental right now. Sample, oh, of the coefficient patterns? Okay. Yeah, I'm not sure. So you pointed out that the coefficients of A1 add to powers of 2, right? And then 8 for pairs, they add to powers of 2. Actually, 11 and 21. 32. Okay, yeah. It's interesting. I don't know if that's an interesting observation. I don't know. how you'd apply it. Just the next numbers up in the sequence. Yeah. If k1 and k2 greater than root 2, then the sequence is eventually bound by a geometric series. Show converges. Oh, it's less than root 2? Does the geometric series not apply? I'm not sure. I'm getting like really mentally tired. These have been some really fun problems. I just need to come back to them with a fresh mind.